Good morning, everyone. Happy Tuesday and welcome to our Tuesday edition of our Natural Scotland live lesson. I'm so glad to have you with us today. We've got a lot of exciting lesson for you today. Let's take a recap of what we learned yesterday, shall we? Of course, yesterday was all about animals. Pardon me, all about animals. And today is all about geology. Now, if you don't know what that is yet, you're in for a treat. It's all about how Scotland was formed and how different it has been to what we know of Scotland now, to what we're familiar with right now. And Wednesday's about rainforests and Thursday's about folk stories. So what can you remember from yesterday? If you were with us yesterday, there may be some things that you remember from our lesson. Don't worry, if you've missed yesterday's lesson, you can catch up on it because the recording is on our website. Okay, is this animal native to Scotland? What do you think? First of all, you need to figure out what it is. You need to remember what it is. And then, is it native to Scotland? Is it a native animal to Scotland? What do you think? Put your answers in the chat if you like, or if you want in your classroom, thumbs up for native, thumbs down for not, although that's a bit judgmental. Let's try one hand up for native and two for no, not native, was not. Oh, that's a mink, someone says. It's a pine marten, someone else says. Another class has just said, nope, non-native. Need to guess the animal too. What do you think? Let's see. Oh, right. Oh, it's an American mink. Ah, and a mink with a nationality. Very good. Those of you who said mink are correct. This is a mink. Pine martens look similar, but that's not. This one is not one. And a mink is not a native Scottish animal. Let's try another one. Oh, I like this one. What do you think? Is this animal native to Scotland? What do you think? Need to guess or remember the animal and then guess if it's native or not. Oh, loads of guesses already. Everyone's saying it's a wildcat and it is a native animal. And you're all correct. Yes, this is a Scottish wildcat and they are a native animal. And you remember Jasper was talking about how endangered they are. And he was also talking about the efforts that the Royal Zoological Society of Scotland are making to conserve these beautiful animals. Can you remember some of the threats that wildcats are facing? So we've said that they're in danger, but can you remember why they're in danger? There's a couple of reasons. Anyone remember one of the reasons why these beautiful animals are endangered? Why the Zoological Society has to do so much work in conserving? Oh, Mills Primary has said they're breeding with domestic cats. Yes, that is exactly right. So they are breeding with domestic cats that are let loose and roaming around. And because they're a similar species, they're able to have offspring. But those offspring are produced from cats that are not a native species. So they're not as able to put up with our weather. So they're not the same as a wildcat. They're what Jasper described as a hybrid species. Okay. So today, well done, everyone, for a start. Well done for remembering all of that. Good job. You've obviously been paying lots of attention. Today, we were going to bring you a presentation for our friends at the Northwest Highlands Geopark. But unfortunately, they've had a couple of issues and they can't make it today. So instead, I'm going to hand over to my colleague, Andrea Gabriel, who is going to teach us a lot of really cool things about Scotland's geology and about how our beautiful familiar landscape was formed. Hi, Andrea.
Morning, Kat. Morning,
Morning.
everyone. Oh, thank you. I'm so sorry that I'm your substitute teacher today, but we do have lots of very nice things to show you and to learn about today. And hopefully we might have a surprise towards the end of the lesson too. So I'm just going to take control of this presentation, and then we can start moving on. And let me see if now cat. Very sorry, but I'm not sure if I have taken control out of it.
You should be able to. I got a pop-up that said allow. There you go. That's
there we
you.
Go.
You're driving now.
And there we go. So that's the first question that I have for you today. And this is not a tricky question, and I'm not trying to trick you on a specific answer. I think I know which answer I would say, but which of these two pictures and landscapes do you think you find more exciting? Is it A or is it B? Have a think. I think you might be answering the same way I would be answering. I can see an A already. Yeah. I think A would be for me as well. Now, what about this landscape? Which of these do you find more exciting? Is going to be A, this landscape with glaciers on it, or B, a valley? Have a think. You're half-half. Oh, I like that. Miss Brown's classes, A as well. We like both, mostly B. Mostly B, I like that. Well, I personally think that glaciers are really, really, really exciting. But I like B. That doesn't mean that one is better than the other one. And what about this one? Which one do you think is more exciting? A volcano erupting, or B, a place that you might have seen? Don't know if any one of you can recognize what's B. I think we're all agreeing as well that A might be a little bit more exciting than B. Can anyone guess what's B? That you want Arthur seat? Yes, primary 5-6. That's a really, really, really good answer. That is Arthur seat. Now, what do you think all of these three photos that I show you that we're comparing to other photos have in common? What do you think these three images have in common? They're all in Scotland, all in Scotland. I can see some answers coming. They're all in Scotland. Hills and grassy, and yes, they are all in Scotland. And you know what they also have in common? That they used to look like the photos that I was showing you before. So the hills that we have at the moment in Scotland, believe it or not, used to be as high as the Himalayas or as the Alps. And our grassy, beautiful valleys that are so soft these days used to be covered in glaciers, and not just one time. They were covered in glaciers more than once. Sometimes Scotland was covered fully by glaciers. Sometimes it was just in little parts of the country. But some of the glaciers were as high as what Ben Nevis is today. So they were really, really, really high sheets of glacier that we were under in Scotland. And I thought this was really exciting when we were putting this lesson together. You know what what Arthur said is? Give me an idea. What do you think Arthur said used to be? Looking at this photo under. I have my chat next to me, so I'm looking at your answers. An extinct volcano. Well done. Primary 5-6 and Mrs. Ferguson volcano. It used to be a volcano, and it didn't just used to be a volcano, because I've heard that Arthur Seat used to be a volcano, but what I didn't know is what we see of Arthur Seat today is not the outside of the volcano, it's actually the lava bit that used to be inside the volcano. So all the rest of the mountain has been washed away, and we just see what was left of the lava. Isn't that cool? It's really interesting. Did any of you know that? Well, I didn't know that before. Now, how do you think that was possible? How is it that Scotland used to have mountains as high as the Himalayas, but now they're not as high. And how did we used to have all these glaciers, but now there's none? Or that Arthur Seat or other extinct volcanoes used to be these much bigger volcanoes, and now it's just the bit that is left with the lava inside. But what do you think happened? Erosion, says Mrs. Ferguson's class. Our mountains are much older, says primary 5-6. Good answer. Any other thoughts? Erosion. And basically, yes, it is erosion. And it is that we have much older mountains. So lots and lots of things have happened during the time that these mountains were here or the glaciers were here, because the thing is that Scotland has an incredibly old and interesting geological or land formation history. So some bits of Scotland are as old as 3 billion years old. And that's almost as old as the Earth, because the planet, our planet, is only 4.6 billion years old. And some bits that we can find in Scotland are 3 billion years old. And it is a bit tricky to think, like, how is that possible? Because we live in a planet that has been as a planet since it started as a planet, isn't it? So it's a bit strange to think that some bits of the planet are older and some bits of the planet are younger. But let me just give you an idea with these images. So some of our mountains, as you were saying, are really, really old. And for example, the Nevis or Ben Macdui that you can see there, that is one of the mountains that you can find in the Cairngorms National Park that we were listening about, that we were learning about yesterday. They were formed around 480 million years old, which as a number, it's very hard to know and to understand what it looks like where did that happen. But just to give you an idea, 480 million years ago, we mainly had life only under the sea, and few plants were beginning to live outside outside the sea in the land, but there wasn't much life as animals living outside the sea. Whereas Mount Everest, or Chomolungma, as you can see the name, that's the Tibetan name. So that's the real proper name for Mount Everest in the Himalayas. That's a baby mountain that was created around 60 to 50 million years old. So the Himalayas are a lot younger than what the Cairngorms, for example, are. So the Himalayas were created, let's say, like 5 million years after that big asteroid crashed the air and wiped the dinosaurs. So long after the dinosaurs, whereas our mountains here in Scotland, long before the dinosaurs. Can you think of any other chain of mountains that you think might be as young as the Himalayas? Which other big, tall mountains do you know that exist in the planet that might be that high because they're quite young? Have a think. The Alps, fantastic. That's a great answer. Yes, exactly. The Alps are very similar in that sense to the Himalayas. They're kind of baby mountains as well. And I'll tell you another one. And I like this one because this is close to my home. Actually, this is the picture of where I come from. Can you guess where this is? This is a very tricky one. So I'm not expecting you might know where I'm from, but try to guess. It's not the Alps because you already mentioned the Alps as an example. Oh, yes, it is the Andes and it is Chile. I am very surprised. I am very flattered that you know this is Chile. And that's the mountains that I used to have on the back of where I used to live. So every day I would see the Andes there, and the Andes are as young as the Alps and the Himalayas, maybe slightly even younger. So that's how just to give you an idea of why we have some bits in the world that are older and some bits are in the world that are younger. And how does this happen? Well, the thing is that the planet that we know, that how it looks at the moment, hasn't really been like this for all the time. So our beautiful continents that we have learned and we know and we named and we have divided in different countries haven't been exactly the same all the time. And just to give you a little idea of how much change has happened in this planet, not even going to show you the entire history of the planet here, just a little bit. It's not even 10% of the movement, but this is a fantastic video I found that can help you understand how these masses of land have moved across the time and have created little by little what we know as our planet, but it hasn't really necessarily been like that all the time. So here we're back to being in, there we go, 300 million, 200 million, we're getting close to 150 million years ago, 100 million, and that's when our continents, as we know, started happening. Sorry, I'm going to go one back. Now I'm going to ask lovely cats. Whoop. Here we go. So ignore this one, and I'm going to stop presenting, and I'm going to ask Kat if she can come back in camera, because we have another way of showing you how these mountains were formed. So before we move into this slide, Kat, would it be possible you can come back into camera and help me show how these mountains were made just by this mass of land moving and crashing?
Yes, I would love to, but I need a mouse and I'm having a bit of a hard time here. Yeah, I can see your mouse, but I can't see mine. This is I'm the one having the technical gremlins today. I'll tell you what, I've joined on my phone as well, so I will show you this way, okay? Hold on.
Super, and I just stopped controlling the slide, so maybe now you can see your mouse?
There it is. Okay, hold on. Slightly different view now, so you can see the table. Let me see if I can zoom in. Hey, look at that.
Oh, that looks great.
Isn't it? Very cool. We're very technical here, and you're getting a backstage view into our live lesson. This is where it all happens. Okay, so you can see, so I have some towels. I hope you can still hear me.
Yes, we can.
Yeah. I have some towels here, and these represent the layers of rock and sediment, right? So I've got 4, just like a cake, right? There's all kinds of layers. And I'm going to turn it so that you can see the edge, right, with all the layers. Now, what happens when mountains form is, like Andrea was saying, the two forces push all of the layers up like this. They push and everything folds and buckles. And you can see how all the layers here have formed mountains and hills, but all the sediments and layers of rocks stay where they are. They just push against each other and buckle up to form mountains. Now, I know that this is a little bit hard to see, so it might be a cool idea to try this in your class with some layers of blankets or towels or jackets, right? And you can push on either side and see just how the forces buckle and how it's different every time, right? So if I do it again, it'll form a slightly different pattern. Whoop, there goes the camera. I bumped a wire, I'm so sorry. But yeah, that is something you can try in your classroom as well and make your very own mountains out of cloth or towels. It's a very good demonstration of the forces and how they push up.
That was
Right.
a brilliant demonstration. Thank you so much, Kaz.
No
And
worries.
yeah, so what happened with our mountains is that those layers of those masses of continent crashed together a long time before the ones that crashed together from forming the Alps or the Himalayas or the Andes, for example. Now, can you see the slide in the main control in your screen, or can you see just the bubbles with names? There we go. I think, yeah.
No, I can see the slides. They're all yours.
Fantastic. Thank you very much. So that's what happened, not in one place in Scotland, but in quite a few places in Scotland. Actually, quite a few places. It's really interesting what we can find here. So here's a map of Unfortunately, this map doesn't include Shetland in the map, but don't worry, I don't know if we have anyone joining us from Shetland today, but I have a special slide for Shetland as well. But can you see in this map here, where, because we can still see it, where different masses of land crash together? Where do you think we could have had a crash of different masses of land creating interesting forms? Now I think, because it's very interesting because you can see it from the space. Any idea? It's a tricky one. Oh, between Fort William and Inverness. Oh, yes. Well done, Primary 5-6. So have you seen that line going there? I don't know if you can see the cursor in my cursor moving on your screen, but well pointed for on the darker green brown bits. Yeah, you can see. So we can clearly see two very different lines that make us think, oh, that looks quite different one side on the other. So one is the line of lochs that happen around between Fort William and Inverness, as you were saying. Then we can see that above Perth, above Stirling, above Glasgow, looks quite different on one side and then on the other, isn't it? So we do have, and I'm going to show you now, and these are lines that are not exact because I drew them myself, but we do have 4 different, oh, where's my thingy? So I'm just trying to go to the next bit of the slide, but I can move the control. There we go. That's it. So we have actually 4 fault lines. Fault lines are what we call where the masses of continent have crashed. And we have 4, and the one that we know most of it is the Great Glen one, which is the one between Inverness and Fort William, as some of you were saying. And the other one is the Highland Boundary Fault that we can still see like really, really well. But we have a surprise for you, and I really hope that the surprise is nearby. Because the best way of understanding and of seeing like how this is possible and how different it could be, one side of or one bit of the continent that crashed with the other bit, is to actually go there. So let's see if we have Joe somewhere, and because our colleague Joe is not going to join us on the screen like Kat or I from a desk and inside the office, but he's actually out there. There he is. Thank you, Joe.
Hello, morning.
Good morning.
Can you see and hear me okay?
Yeah, we can see you and we can hear you, and I'm about to spotlight you for everyone so you can be big on the screen for everyone.
Fantastic. Well, good morning, everyone. That's okay, Andrea, I can wait.
Super. There you go. All yours.
There we go. Am I really big on the front screen now? Fantastic. Thank you. So good morning, everyone. So as Andrea says, hopefully we've got a wee bit of a surprise, and that is that I am this morning on Conic Hill at the south of Loch Lomond. And just as Andrea says, this is because this is one of the fabulous places in Scotland, particularly close to where we are in Stirling, to be able to see one of these fault lines. And as we've just discussed, that is the Highland Boundary Fault. Now, actually, if you can see behind me, the evidence of the Highland Boundary Fault, and the reason why I'm on Conic Hill just now, is these group of islands just behind my shoulder just here. So you can see that they're in quite a strange line for some islands. So that is because they sit on the Highland Boundary Fault, which runs 140 miles all the way across Scotland, just like on the map we just had a look at, from the Isle of Bute and Helensburgh on the mainland, all the way across to Stonehaven. So 140 miles that cuts across it, and it will probably pass some areas that may well be quite close to you. It goes through Aberfoyle, and it goes through near Conwy, north of Crieff, north of Perth, and then up through Angus and Kirriemuir. Now, the reason why these rocks, these islands are in such a strange alignment straight across Loch Lomond is because they are sitting on this Highland Boundary Fault. So when the glaciers melted and the water rose to form Loch Lomond, this line of islands remained as really obvious points. So I'd like for anybody to put in the chat if, for example, you have been up to Conic Hill and you've seen the islands, or if you have got any other evidence of a fault line near you. That might be some rocks, or it might be some interesting geology, and we'll have a bit of a talk further about these on our journey. You probably mentioned in the chat, and we will go to some different areas to have a bit more of a chat. So we're going to go for a journey over this way, and it's going to get a little bit windy. So I've just dropped off the summit of Conic Hill just now because it's a little bit windy on the top, but I'm going to go up to a more exposed sections to explain the next wee bit so that you can see it really clearly. So hopefully you should still be able to hear me, even though it's got a bit windier. So when we're talking about a fault line, just as Andrea says, we're talking about two parts of the Earth crust which collide or come together. Now, the geologists think that the Highland Boundary Fault was formed from two pieces of continental crust that came from what is now North America and also what is now a part of Europe. And the Highland Boundary Fault, when the plates came together, they mushed up, just like in Kat's example with the towels just there. They mushed up and they rolled up and they formed hills that were kilometers, mountains that were 15 kilometers high. So that's higher than the Alps are today. So just as Andrea was saying earlier on, they formed these huge mountains, much higher than some of the ones much higher than they are now, and much higher than some of the ones we have in other areas of the world. And the Highland Boundary Fault is so particularly interesting because it forms the boundary in Scotland between the Highlands and the Lowlands. So if I stand on this slightly more exposed section just here, hopefully you can still see the line of islands on Loch Lomond behind me. And then to the south, you'll see that the geography, the topography is a lot flatter. So all of this flat area, and then we go back to the Highland Boundary Fault, and then to the north, it's all mountainous. So hopefully you should be able to see that the highlands in the north and the lowlands in the south, and then the Highland Boundary Fault is where they meet. So we often talk about the Highland Boundary Fault being the boundary between the highlands and the lowlands of Scotland. So I'm going to find a slightly more sheltered spot again, and we'll have a talk about some of the rock types that made this happen. So we're going to go over this way. And I'll find a spot just hunkered down here. So hopefully this should be nice and sheltered. So you can see an example of the different rock types here. So behind me here, we have this type of rock called conglomerate, which is this lumps of pebbly, smaller pebbles. If I find one on the floor here, smaller pebbles that are mushed up into a bigger rock that's held together with other materials and matter, such as like silica and things that are sandy rocks, and it's held together in this kind of like big mushed up ball, so that it's got these what we call pudding stones, so these big round pebbles with the sandstone in between. So this was conglomerate, and conglomerate is the word, it means to kind of like mix things up as well. Now, the other rock type that we have in the Highland Boundary Fault, because I'm sat on Conic Hill, which is a big conglomerate lump, I haven't been able to find, but it's okay because I brought some down from Loch Lomond and Balmaha, where I started this morning, and that's this rock type, which is red sandstone. So this is much more of a normal sandstone that you might see, particularly if you live somewhere near some cliffs in Angus and areas such as that. And that is the other rock type. So we've got conglomerate and red sandstone. And when these two plate boundaries smush together, those two rock types kind of like collided and they got all mixed up together, and there became a really obvious difference in where the conglomerate, the lumpy rock, stops and the red sandstone starts. And the way that we can see that, as I say, is in areas such as cliffs. And if you are really lucky, you go to areas such as Conic Hill or into areas of Aberfoyle, you can see where the different parts of the rock meet, and it's all wavy, and you'll see on one side there's the red sandstone, on the other side it is the conglomerate. So if you go to some of the areas around the Highland Boundary Fault, you will find these nice soft brown pebbles, maybe even some pieces of quartz mixed in there as well. And then you'll see the other type of the red sandstone. Oh, the sun's coming out. This is fantastic. Look at this. So because the sun's coming out, we'll go back and we'll have a look at the view again. You can see just down to Balmahala I started this morning and across to Loch Lomond. So the hills and the rain clouds have cleared just a little bit. So I'm going to show you again the Highland area. So it is still windy. So they're the Highlands up in the north with the Araka Alps and the Highlands down there. And down in this nice sun trap down at the bottom, you will see the lowlands and this flatter area at the bottom. So I think that's all from me. If you've got any questions, please don't hesitate to put them in the chat. I'll turn my camera off to save the battery. I'll be typing away if you do want to. I'm going to nip down to my shelter spot again, so I can go down this way.
Thanks so much, Joe. That was amazing, and we were so lucky that the showers passed before, and that they allow you to deliver this fantastic lesson. Thank you so much for going up early in the morning up the hill.
Not at all. I've just remembered that somebody did ask me earlier on the age. So we talked about how old things were earlier, Andrea. So I'm just going to say that the Highland Boundary Fault was formed about 400 million years ago. So that just shows how old the geology is in this part of Scotland.
Thank you so much, Joe. And Kat, could you pop the slides back in, please? Fantastic. I'll just take control a little bit because we're about to finish our lesson, and I hope you've been enjoying. But just because I said that we had another slide from Shetland that we couldn't cover in this map, look at that. That's amazing. We were very, very lucky that the Shetland Amenity Trust was happy for us to share with you this. But Shetland, which is a group of islands quite north from Scotland, they have as well like 3 different fault lines. So, and they're all really, really old as well. So how interesting is the geology of Scotland? And we really hope that after today's lesson, you might feel there is a lot more to research and to learn about. This is just a little window for you to see and to learn that we have lots and lots of interesting things in Scotland that it's worth learning about and worth caring about and worth looking after them. But that's from me. And thank you very much for having me on your screen this morning. And
that was just brilliant. I'm so glad that the weather held out for Joe to be able to be up that hill for us. It's just amazing. We weren't sure if that was going to work, were we? But hey, look at that. It's worked fine. Brilliant. Just trying to find my cursor again. Please hold. There we go. So if you have any more questions for Joe about the geology of Scotland and the age of rocks and I mean, what a brilliant advertisement for working for Keep Scotland Beautiful as well, Joe. Well done. Please put them in the chat, or you can email them to us as well, and we will look at answers to those questions for the assembly later on this week on Friday. So I hope you enjoyed today's lesson. If you did, thumbs up, a little bit, thumbs sideways. If you didn't, really, thumbs down. And your feedback helps us to make better lessons, especially from pupils. Please let us know what you think. If there's anything else you want us to talk about or cover, any other topics. Kids, if you're interested in any other topics, please do let us know, because we're always looking for ideas. Joe, someone is asking how old the rocks are. I think you were talking about the age of the area in general, but maybe that's a question you could either answer just quickly now, or we can, if it's a long answer, we can save it for the assembly. It's up to you.
Well, I can give a brief answer now. So because they're two different types of rocks, they've got two different ages. But the older conglomerate rock is up to 650 million years old. And what I always find interesting about the conglomerate is it looks like it should be falling apart, but it's actually one of the hardest ones because it's been smushed together in this sedimentary process so much more. So yeah, 650. And red sandstone, oh, that is a good question. I'm not sure about red sandstone. Less than that, it's a younger rock.
That's okay. We can find out for the assembly. We'll talk about some red sandstone and how old it is at the assembly. That's a brilliant question. 600 million years. The numbers are just blowing my mind. It's amazing. Oh, there. Can you tell us one thing you've learned today? One thing. I mean, I've learned so much. Geography was a subject I really enjoyed in school. So I've really enjoyed today's lesson, and I've learned a lot about Scottish geological history. And I find it fascinating that you can see the fault lines even from space. That's amazing. What was one thing that you have learned today that you're going to take away with your favorite thing that you've learned today? You can put that in the chat if you want, or just discuss in your class as well. While I move on, let's see, what would we like you to do today? So while you're thinking about the thing that you've learned today that you enjoyed the most, so there's comments coming through already about how old mountains are, almost 500 million years old. Yes, those numbers are sticking in my head as well. It's so amazing. Right, so today we would like you to build your own Scottish map. Okay, so in the folder of activities that your teachers have. Now, teachers, if you have misplaced the link for the folder of activities, please just let us know by emailing us at ecoschools@keepscotlandbeautiful.org, and we'll send you the link again, because there's a folder full of great stuff for your class to do in there. And today's activity is a group map of Scotland, and you're going to create a map in groups, and you can start adding to your map the different things that we have learned throughout today. So maybe you want to add where you are, where you live, where your school is, which will be very close together, obviously. But you could add fault lines. You could add where the mountain ranges are, right? Maybe you want to mark on the map places you have been on holiday as well, because that will help you get familiar with the geography. Okay, now as always, we always invite you to say hello and share your work with us. If you'd like to send us a picture, you watching the lesson and wave hi. We just love to see that. Please, teachers, if you do send us photographs, please let us know if it's okay to share these in Friday's assembly, because we love to see your smiling faces and share that with everyone. And can you let us know what your maps look like too? We'd love to see your maps. And yesterday's activity too, we'd love to see examples of you doing that. Let us know how you got on with your other activity. If you haven't watched yesterday's lesson, I won't give away what it is, but it's very cool. Thank you so much for joining us. Thank you, Joe, for climbing up a hill first thing in the morning. Dedication to the job right there. Thank you, Andrea, for teaching us all about different mountain ranges and how they're formed. And thank you to all the classes who joined us today. It's a pleasure to have you with us, and we hope that you can join us tomorrow too. Until then, bye for now.